Welcome back, everyone. So this is the second part of the video where we're automating the creation of thumbnails for videos uploaded into our S3 bucket via Lambda, SAM, and Python. So if we recall, we created a function called generate thumbnail, and it basically receives a video and returns our thumbnail.png file. So I've kind of deleted the video here. I also have my thumbnail file here. So I'm just going to take my video and my thumbnail files out. So now what I want to do is I want to create my Lambda function, and I want to test my Lambda function on my local machine using AWS SAM. So that's what we're going to be doing in this video. First, I would need to open my terminal. Now, before we get started, for this video, you're going to need the SAM CLI. So here where we have the AWS Serverless Application Model documentation. So there's a part that says installing the SAM CLI. It's quite basic and straightforward. So you just have to download the zip file. And once you're done downloading the zip file, you unzip and you run sudo SAM. There are also installation mediums for Mac OS and Windows. So I use Linux, so I just follow this installation process. It's quite simple. And also, before you install the SAM CLI, you need to have your AWS CLI. So I'm under the assumptions that everyone has their AWS CLI. Now, first, to create my SAM template, I'm going to be running a command called SAM init. And it's going to ask me what template would you like to add. So I would want to start with what I call a quick start template. So I would choose sorry, I would choose the hello world example. So one, use the most popular runtime and package type. I'm not going to be using the most popular runtime and package type. This time around, I'm going to be using a maybe a custom runtime. So I would not say a custom runtime, but a runtime that's specific to what I'm using to develop. So I use Python 3.10. To check that out, I can run Python version, and yes, Python 3.10.4. So I would want to press no. Then I would go for the Python 3.10 runtime. So that would be 18. What package type would you like to use, zip or image? I would want to go for the image package type. Why? Because when we're trying to deploy to SAM, it's very possible that our dependencies are larger than the standard 250 megabyte size. So I would want images. And I think for images, you can basically have dependencies up to 10 gig. Basically, depending on the type of applications you're trying to build. Maybe you might have a machine learning model or something. So would you like to enable extra tracing on your function? Yes. CloudWatch, yes. And my project name, I would call it Tumber vid, or I'll call it Tumber. I think Tumber vid will be fine. Tumber vid. Good. So now that I have this, I can see that a new folder called tumblevid has been created. So I can go into my CD. I can CD into my tumblevid folder, and I basically have my hello_world folder. This is where I'm going to be writing my code. I have my requirements.txt, my Docker file, and my app.py file, and also Docker file requirements.txt. Now I would need to work in this space called my app.py. This is where I'm going to be developing my Lambda function. I'm going to take this out. So here I'm going to be writing my code. So there's something called an event. Now events are basically a JSON data that is sent to AWS. So when AWS wants to get an event, the events are sent as JSON. So events are basically JSON data received by AWS. So I can decide to build this and test this out. To test events with locally on our computer, we have an event.json file here. And this event.json file, once we kind of reference it in our SAM local invoke, it's going to be used in our Lambda function while we're testing locally. So I'm just gonna, I want to be sure that my application works. So I'm going to be printing event. So event.json. Now, since we're going to be testing our file upload, and we basically want to test we want our Lambda function to be triggered when a video file is uploaded in our S3 bucket. I'm going to be replacing our event with an event that looks more like something with a file upload. So I have a Lambda function called blue RDC, and my Lambda function triggers is a Lambda function that basically retrieves metadata for objects that has been created in an S3 bucket. So here, one of the logs, I uploaded a video into an S3 bucket, and the name of my bucket should be, let me see. So I think that should be test vidbug3. Yes, so I have a video.mp4 in my test vidbug3. So when I upload a video in test vidbug3, this Lambda function gets triggered and it prints out the metadata. So here's what the code looks like. Loading my function. Okay, while that loads, we're also trying to load our CloudWatch metrics, which is basically our data. So here is what an event looks like. So I'm sending an event to S3, and this is what my event looks like. So when a file is uploaded to the testvidbug3 bucket, the event is basically printed out. As you can see, here's what the code looks like: print event, and then I would then have this event. So I'm just going to copy this out. I'm gonna have to paste this here. So there are some things that have to do with formatting. So I would have to replace all my single quotes with double quotes. So that's great. And VS Code allows us to format document. Yes, so this is our event. So once we run this Lambda function, we're going to be having this event.json printed out here. So how do we test that? We can test that with SAM build. We can test that with SAM build. I think that should be SAM. We'll start with SAM build. Would need to build our SAM package, so our SAM application. So SAM build catched. Now what I'm trying to do is I'm trying to ensure that my build is catched. So the next time I'm trying to run a build, I don't have to wait for long. So I'm just going to wait for all these requirements to be installed, then we move forward. All right. Now that we have our SAM build program complete, I'm just going to run SAM local. To test your Lambda function locally, you'd have to invoke the function like it's written here. So I'm going to run SAM local invoke. Now I want to reference, okay, what's the name of my Lambda function? The name of my Lambda function is hello world function. So I'm going to have hello world function. And once that's done, I'm going to reference my event, and that will be in the events/event.json. So first, this is going to build an image, and once it's done building an image, our Lambda function runs. So let's see how that goes. It's using our local image. Great. So as you can see, this is similar to what we have in our event.json. Event source, AWS S3, key, video.mp4. So that's what an event looks like. So now let's get started into writing our code for our Lambda function that's going to be responsible for our thumbnail generation. So in my app.py, you can see I have a function that basically generates my thumbnail. I wrote that in the first part of the video. If you're just joining, you can check out the first part of the video. So I'm gonna go here. I'm gonna copy this. Once I have this copied, and I'm gonna go to my app.py and I'll paste this right over here. So okay, it seems like something went wrong with the copying, so I didn't get all that. All right, great. So Ctrl+Z, and I'm just gonna copy again. So great. And also I'm going to be importing all the files we need. We're not going to be needing the import IO library anymore, since this is going to be getting our function from Lambda directly. So import JSON, import CVT, import API, import mg.io. I guess that's everything we need. Now also we're going to be needing the Boto3 package. Like I said, we're going to be using Boto to get our video data from S3, and we're also going to be writing our image to thumbnail folder from S3. So to do that, let's write our code for that. So first we're going to need to def, let me see, I would want to write a function that uploads to S3 or downloads from S3. So I'm going to name this get video file. So this is going to expect the name of a bucket and the key, which is the name of the file. So dev get video underscore file, and video, my video underscore file, I'll define my video underscore file to be S3. Okay, I'll need to set up my Boto client. S3 equals Boto.client, sorry, Boto3.client. That should be S3. Great. So now to upload an S3, to upload an object to S3 via Boto, you use the S3 get underscore object. So when you use the S3 get underscore object, it's basically responsible for uploading a file to S3. So it's going to take in an argument of bucket. So we'll pass in the bucket name, and it's also going to take in the key also, and we pass in the key. So with this we can basically get the files from our bucket. Now S3.get object returns a JSON, and in our JSON it returns our body, and the body is basically a stream, I think a streamable file input from S3. So we can read that as bytes. So we're going to read that, and we're going to return the video file. So return video underscore file. So this is basically what our code should look like. And also we're also going to write a function that's going to upload an image to S3. So S3 upload image, I'll call this upload image file, and I'm going to it's going to take an argument of my image byte data. If we recall, our generate thumbnail function takes in our video byte data, and it returns our thumbnail byte, which is basically our image data. It returns it as a byte. So I'm going to be having this passed to here. I'm also going to need to have what I call the bucket name. And lastly, I'm going to have the that will be the key. The key is going to be the name of the file. So it could be name.png or file.png. So to upload to an S3 bucket, we'll just have to use our S3.put object, which is a function that allows us to upload our files to S3. So we can specify our buckets to be the name of the bucket. We can also specify our key to be the key we're passing, which is going to be the name of our file. Then we'll specify the body, which is the image byte data. And lastly, if you want, you can specify your content type. I would want AWS to treat this as an image, so I'm going to pass in content type image.png. So now that we have that, we have our get video file and upload underscore image file. We're good to go. So first, we need to get this event from S3. We're receiving, we're getting our objects, we're getting our key, we're getting our size. So we're receiving a record array. So in the record array, we're going to be needing to get, we're going to be having, I think, a JSON object, and we'll need to reach out for the S3. And once we reach out for the S3, we'll also need to reach out for the bucket and the object. So I think we can do that. Yes, okay. Rather than having to do that, yes, this part of the code does that. So I'll just have this. This is my old Lambda function that basically retrieves metadata from an object. So I'm just going to take it out now. Let's focus on what we're trying to build. Now I'm going to go to the app.py because I do not want us to get confused using this app.py. I'm going to take this out, and we don't really need this anymore since we're using our Lambda function now. So I'm going to delete this. So great, we can say bye-bye to our old app.py. Now in my Lambda handler, I'm going to be getting the name of my bucket. I also want to get the key, which is the name of my file. So I'm getting an event, and which says records, right? I'm also getting the JSON object in the first index, and I'm going for S3. So inside this S3, we have the bucket, and we also have, if we look closely, I think it's quite clear that we have the object here and the key. So I would be referencing the object and the key. Event records S3 object key. Good. So I think we're good. So now to get my video file from S3, I'm just going to run the command get. I'm going to call the function get video file. And once I call the function get the video file, I pass in my bucket name and my key, which is the name of my file. So that works well. Also, the data I get from this video file, I want it to be in an output. So that will be, I'll call this image output file. So I'm going to call the generate thumbnail function. If you recall, this is taking a byte, so I'm going to pass in my video underscore file. Now that I have this, then I'm going to call my function which uploads image to S3. It's expecting my image data, so that'll be image output file. I'm also going to pass in the bucket name. So I already have a bucket here. I think I have a bucket called thumbnail 876. So I'm going to use that bucket. So thumbnail 876, and I hope that's spelled correctly. In situations where you make mistakes here, you might get an error, so you have to get this name correctly. So for the name of our file, I want the name of our image file, our thumbnail file, to be the same as the name of our video file. So if we have a video called video.mp4, I would want my thumbnail file to be video.png. So I'm going to take the key, right, and I'm going to split it with a period. And once I have this, I'm going to take the first item in the array, and I'm gonna add the dot. I'm gonna add the dot PNG extension to it. So I think that was key dot split dot. So what we do is we have basically a file called video.mp4, and the dot is basically the reference point for splitting. So we basically have two values into our array, which is our video and .png. So we take the video and add it with the .png. So that's how that works. So once we upload our video file, we can then have a successful code. So now that we have this, I think we're done. I think we don't have anything we're trying to bother about. So it seems like good. So now, before I build this code, I have a requirements.txt file here, which is basically where I'm supposed to add my requirement. So to get my requirements, I would need to check my virtual environment. So pip freeze. Okay, I see I'm using the pillow, I'm using the NumPy and OpenCV package. So OpenCV, Python and AWS. So I'm going to save this. Now, we're also going to be using the Boto3. But there's a package I need to add called, I think that should be, I would want to look that up right now, URL lib. Let's see. URL lib. So I would want to add that, or let me see, I could use URL lib 3. Good, URL lib 3. So I'm going to be adding the urllib3 package. So urllib3 here. And now, why am I using the urllib3? The reason is because in some situations we might have some dependency problems between Bodo3 and request on urllib. So I really want to avoid that. So I'm going to specify a urllib2 less than 2, which means a version less than 2. So let's see how that goes. So I'm going to clear this. Now, to check if this works, I'm going to build our SAM application with SAM build. So this time the build is going to take longer because we added new requirements, which are the urllib, numpy, OpenCV, Python, headless, and pillow. So yes, as we can see, urllib got installed, numpy got installed. So I'm just going to wait for this to be done, and then we run SAM invoke. Okay, our SAM build program is done. So our code is done. So I'm just going to run the SAM local invoke right now. Now this is building our image. Now there's something that basically occurred to me right now. In my template.yam, I have my timeout to be 3 seconds. So it's possible this function fails to go. This function is probably not going to complete execution. That's yes, because it's timed out after 3 seconds. So in cases where you need to increase when you're trying to perform an operation that basically takes a long time, like in our situation, we're working with image processing and video processing. So we might need to increase this to 120 seconds. Not that it's going to take this long, but we're taking into account different type of scenarios that whatever happens, we're going to give this Lambda function 120 seconds. And there's a maximum time you can give Lambda functions, that's 15 minutes. It's advisable that any workload you have that exceeds 15 minutes, you might probably need to shift this to a high compute EC2 instance or something else. So we're going to give it 120 seconds. Now we're going to use the SAM build. I think I'm going to add the catched command this time around, and just to ensure that I do not have to okay, good. I think that was fast because all my dependencies were already downloaded before. So I'm just going to run SAM local invoke immediately. That was fast. So let's see where that gets to. We want to be sure that our function runs. Okay, so we have our output here. I got an error that says byte object has no attribute get value. So okay, that seems to be a problem here. Video byte data the get value. Okay, I think I know where the problem is. So here's the thing. Prior to when we were creating this thumbnail application, we're passing a video file and we were using bytes IO. So our video byte data was basically an IO.byte IO file. So this time around, it's not an IO.byte IO file. It's basically a byte file. So S3 is giving us a byte file. So we do not need to use this get value anymore since our video byte data is already in bytes and not byte IO, IO.byte IO. So I'm just going to remove this get value, and I'm going to run this again with SAM build cache. Okay, since this seems to be downloading again, I'm just going to wait for everything to be done. Okay, so our SAM build is done, so we're going to run SAM invoke. I really want this to work, and I'm hoping it works. So SAM local invoke. Okay, it seems we got an error that says parameter validation field unknown input bucket must be one of ACL bucket. It seems like something went wrong somewhere. Parameter validation field must be one of AC3 bucket. So file task app.py line 17. Let's see what's responsible for that. So line 17, that must be okay. I think this should be capital letters. So body, it says, okay, parameter validation field must be one of ACL body bucket catch control. So I this field, because I got the spelling of this wrong, so we're just going to try again, and I think we should have a success. So SAM build cached. Okay. All right, that took a while, but our SAM application is built. So I'm gonna need to run SAM local invoke right now. Okay, our image is done building, and our Lambda function just started running. So we're going to need to wait to get a response. Okay, I got a status code that say 200 body. That means my Lambda function worked. So to kind of be sure that this works, I'm going to need to go to my S3 management console. I'll go to my thumbnail bucket, and wait, I have my video.png file here. And just to be sure it's what we want, we're gonna, oh great, I guess this is what it's supposed to look like, since we have our video to, I'm sorry, my reaction was quite interesting, since this is what our video looks like. Can you see? This is the first frame of our video, so this is what our thumbnail was supposed to look like. So I mean, I guess that works. Now, what do we need to do? We need to deploy our Lambda function. There's something I would like to reference about the Bodo3 package. When you are using the Bodo3 package, you need to ensure you have the necessary permissions to call a get3 object permission and to put object permission. So you basically need permissions to get files from this bucket and basically put objects in this next bucket. So you might need to have some form of permissions that allows you to write. So one rule of AWS is basically for us to give least access. So we might use the S3 core policy. So for that, I'm just going to try to deploy my Lambda function right now. I'm going to take this video out. I'm going to go to my thumbnail, and I would want to delete this. I don't want this video anymore, since I'm going to be using this permanently delete. So delete objects. So that means we have an empty bucket now. So to deploy our applications, we'll need to customize this template or YAML to work with us. So now, working with templates can be very difficult at times. So I'm not going to be creating a template in this video. I'm just going to be copying one. So I have a template on GitHub. So I'm going to copy this. Do not worry, I'm going to make this code available on GitHub. So I have an S3. I'm going to be explaining my template now. So my template has two resources, my bucket and hello world function. So what this first section does is this. It's going to create an S3 bucket, and the name of my bucket will be vid bucket, and this, it will be vid bucket and with an hyphen and my AWS account ID. So why am I using this approach? Normally we could just go we could just go ahead and just do something like vid. I think we could just do something like vid bucket 63 or 63392, but instead we want to use a dynamic name. We do not want to, it's not I would say it's not longer a standard practice. It's not a standard practice to have you add code names such as this. It might lead to things which we call circular dependency errors, where you basically have different type of properties and resources referencing each other. For example, a policy and an event referencing a bucket. So you use this, which makes it easier. So I define my timeout to be 300 seconds. So maybe I might need to reduce that to 200. So 200 seconds for my timeout. I'm still running the Python 3.10. I'm still running the Python 3.10 runtime. And also I have a policy here. Now, the purpose of this policy is to ensure my Lambda function I'm going to be deploying has the necessary permissions to perform an S3 record policy. And what does that mean? The S3 record policy allows Lambda to read, write, create, and update objects in my S3 bucket. So in this my vid bucket, I want Lambda to be able to read. I think I should have just even given this probably an S3 read only permission, since AWS basically tells us to go by the rules of least privilege. So I think that will make more sense. So you could try that out. So I pass in the bucket name. I also give the S3 write policy. Now I'm using the principle of least privilege here. Why? Because in our thumbnail bucket, okay, the name of our thumbnail bucket is not thumbnail 2098, but thumbnail 876. So I'm gonna have to rename this to thumbnail 876. In our thumbnail 876 bucket, we need an access. We need an access to write files to this bucket, because we're basically running s3.put objects to our thumbnail 876, and also we're getting objects from our vid bucket. So when this application is getting created, this policy is going to be added to our Lambda. And lastly, we have an S3 event. So what this does is it tells our Lambda function that, hey, check out these events. You're going to be triggered by this event. So whenever there is an object created event on S3, so someone uploads a file, updates a file, this Lambda function is going to be triggered. So this time around, it's referencing this bucket here. So this is how this template works. So I'm just going to save this, and we're going to get into the process of deploying our application. So we can see our Lambda function works. We've tested it on our local machine. So to run our commands in the command line, I want everything to be visible. So I'm just going to move things a bit small here. So first, we're going to first build our Lambda application again with SAM build. And I'm going to wait for that to complete immediately. And so now that this is done, I'm going to need to do something else. Since I've built this, I'm going to run what we call SAM deploy guided. And what does this do? This basically is going to take our application and deploy it to SAM. So let's try this. SAM deploy guided. Now, when we run SAM deploy guided, we basically have a question: what's our stack name? Our AWS region. I'm going to use the default region. Now, it's very important you ensure that your S3 bucket is basically in the same region as your Lambda function. So I'm using US East 1. So confirm your changes before you deploy. Yes. Allow CLI. I'm going to allow this to be yes. Disable rollback. I don't want to roll back now. Save argument to configuration file, yes. And save samconfig.toml file, yes. So save configuration environment. I wasn't supposed to press Y here, so I'm going to cancel and reinitialize this now again. Okay, so let's go again. Okay, so what's our stack name? Tumbleweed US East 1. I'm going to confirm my changes now. Great. Yes, some config, the default. And what this does is this basically starts to provision our infrastructure. So if we go to check how this works, I'm going to go to cloud formation. So this starts to create a stack name called Tumbleweed in our cloud formation. So it's going to set up the necessary infrastructure. So I think it hasn't started creating our stack yet. So we're just gonna wait for it. All right. So as we can see, it uploaded our template. Now it's basically asking us that do we want to create the stack? So I'm going to confirm that I want the stack created. So it begins to create the stack, and I don't really want to bore you with every details as to how the stack is going to be created. So I'm just going to skip the process of the creation of the stack. So like in case you run into errors, you might need to check Stack Overflow as to what your error is about. But I think based on the things we've done so far, it's easy to follow through and to basically proceed without having errors. So I'm just going to wait. Okay, this is really great and awesome. We can see that our stack has been created and we basically have everything created and our application has been deployed. So if I come back to CloudFormation, I can see that my Tumbleweed stack is here. And let me also go back to Lambda. So as we can see, we basically have our Tumbleweed Lambda function here. And here is what our function is going to look like. So this function belongs to an application. We're seeing this because we created this with AWS SAM. So package size, the deployment of your Lambda function. So this is everything. And if it's okay. Now, if we're going to take a look over here, we're not seeing any triggers. We're not seeing a trigger right now. The reason is because we deployed our application with SAM. It does not mean it's not going to work. It's just that our triggers do not appear because we created it using SAM. But to really test if this bucket actually works, I'm going to go to my S3 bucket. So I'm going to reload this and we're going to see that my vid bucket has been created by AWS SAM. So I'm going to take my vid bucket and I'm going to upload a new file into it. And I'll take my file and I would want to take a video.mp4 that I have here. And it's just 8 megabytes. I'm going to upload that. So I guess that should not take, this is only supposed to take a second, but okay. Great. So I think our upload has been done. So now that's been done, I'm going to close. So first, I'm going to go to Lambda and I'm going to go to logs and I'm going to turn on monitoring. So it's going to keep running and looking for recent invocations. So when our Lambda function is running, it's very possible that we do not see our invocations immediately. So we need to we need to refresh on a frequent basis to ensure that our invocations are made available. So that's not there yet. So just to be certain that we chose the right thing, and I think I called this thumbnail 876. Good. So I don't really want us to make mistakes. I want our Lambda function to work at first trial. So let's refresh this. So I'm just gonna wait until this is ready. So all right, so my invocation to my Lambda function is ready. So I'm just going to take this now. I really hope it works, and let's see how that's going to go. Okay. It seems we're not getting enough records, so no more records within any selected time range. Okay, let me refresh. Okay. Well, if we really want to find out this worked, I can go to my buckets here, and I will just check the thumbnail bucket. If I find a file there, oh, that means it worked. So just to be certain, let's first check my videos. So what kind of video did I upload to my vid bucket? So this is the video I should be uploading. So okay, so this is my Cartoon Network video. So I'm gonna go to my bucket. So I'm expecting a video.png thumbnail with my first frame here. Now I'm gonna open this. Yes, great. So that means that works. So now we have a Lambda function and an application that basically lets us create thumbnails from our S3 bucket. So I'm sure this has been a great ride with all of you, and I really appreciate you joining me throughout this video. So now I want to mention the things I didn't do in this video. So in this code, I did not perform some error handling. I did not necessarily handle exceptions. So if you're going to be using this in a production application, I would recommend you add exception handling, like checking if the video is a type of MP4. Also having exception, and basically exception handling, you return a 500 with an error message if something goes wrong. So that's what I would advise. So overall, I trust we had a great time deploying our application to AWS SAM. So I would also want you to like this video and suggest it to friends that basically want to do things like this. Or if you have a friend interested in AWS, you could suggest it to them. And try to subscribe to Code DIY. I'm going to be posting more videos on how to do amazing stuff with Python, AWS Cloud, and different programming tools. So thank you for joining me. Cheers.